Hello friends, we are discussing communicating sequential process CSP. What is CSP? CSP generally describes the behavior of the real-time systems. For example, vending machines, dining philosophers, and like that. To represent in a mathematical way, we should have some rules to be followed. The basic notations to be followed by everyone. So in this presentation I am explaining about the basic notations of CSP and also the concept of introduction called concurrency. These two topics we are going to deal in this presentation. Concurrency. In this presentation, these are the topics we have to discuss. Introduction of basic notations, introduction of concurrency, how concurrency notation is denoted, concurrency with same alphabets, concurrency with different alphabets. Let us go by one. Let us start with the basic notations of CSP. Alphabet. The alphabet of process P is denoted as alpha, is a symbol, mathematical symbol alpha. VMS equal to coin, chocolate. Alpha VMC is equal to input 1 penny, input 2 penny, small, large, output 1 penny. The words inside the braces are called events. The events here are coin, chocolate, input 1 penny, 2 penny, small, large, output 1 penny are called events, where VMS and VMC are simple vending machine and complex vending machine respectively, which are called processes. So it is denoted by alpha. Basically, alpha of a process is equal to events. So this is basic notation, alphabet. The other notation we introduce is prefix. Let X be an event and let P be a process. Then X then P. Pronounced X then P. The arrow mark, we denote prefix by an arrow mark. X is the small one, which is called event. It should be on left. P is called a process. That should be followed strictly. Right side should be process and the left side should be an event. The next notation is recursion. This notation is used for repetitive events as shown below. So there will be a number of repetitive events occurring one after the other. And so for example, in vending machine, you take after one customer, the other customer also comes and performs the behavior. So it is a repetitive one. For writing in the prefix form, it takes a lot of time to notate. So recursion is used to avoid the large notations. It is a way of simple notation and simple way to describe the behavior of a system. So in the place of so many prefixes, we use recursion. For example, here in this slide, a simple vending machine which serves as many chocolates as required. Generally we write as like this: coin, chocolate. That is the thing. Then this equation is just an alternative for the formal definition. It can be written in a simple way by using recursion as shown below. Simple vending machine equal to mu of x, coin, chocolate events, that coin again chocolate, that is tends then x. So this is a simple way of notation by using the recursion. Next is the choice notation. There will be so many events, two events. In these two events, it will occur or either that event will occur. It is the choice. It is represented as straight line as shown in the slide. Example, consider a machine which offers a choice of two combinations of change for 5 penny. How can you have the combinations? If you insert 5 penny, how many ways, how many combinations are there to return the output, to receive the change for us? So there are many ways obviously. So by using the choice, we notate this process, like in this slide, change 5, that is input 5 penny is, you can get the combination of 1 penny, 1 plus 1 plus 1 3 4 5 2 penny. This is 5 pennies. This is a one combination. Or the symbol is saying choice. You can either get like this 2, 3, 4, 5, 5 penny. So this is the useful of choice notation in CSP. Now we are stepping into the concept of concurrency. Concurrency is an important concept where we can describe the real-time behavior. What is the introduction of concurrency? When two processes are brought together to evolve concurrently, the usual intention is that they will interact with each other. These interactions may be regarded as events that require simultaneous participation of both the processes. Concurrency means generally it is a coincidence. It is occurring simultaneously. That is the word concurrency mean. How concurrency is denoted? The notations are simple. Two parallel lines. If P and Q are processes with the same alphabet, we introduce the notation P concurrent Q. Example. Let us take an example and denote the concurrence. A greedy customer wants to get either a chocolate or toffee without paying, and however he decides later to get only chocolate by paying. Then what happens? He wants only chocolate, not toffee. And also first he decided to get the toffee without the chocolate or toffee without paying, and later by paying he wants to get only chocolate. Let us see, this we are all represented by using the basic notations. We will be representing this one. Greedy customer equal to toffee or chocolate, first thing without paying. After this, or if you insert the money you want only chocolate, so coin chocolate greedy customer. The notation is clear. Next, when this customer is brought together with the machine, VMCT means vending machine customer, never gives a toffee because that customer never wants one after he has paid. Now it is concurrently denoted as greedy customer concurrently vending machine customer is equal to mu x coin chocolate x. See, what is vending machine customer? It gives either toffee or chocolate in each transaction, but what the customer wants? Only chocolate, not toffee. So in this representation we consider only the chocolate here. Coin chocolate x. This is represented as shown concurrently. So this is the having same points, like same alphabet it is having. P and Q processes are having same alphabets in this case. Now we consider the different case. If P and Q are having different alphabet, then events that are in both their alphabets require simultaneous participation of both P and Q, as in the previous case also. But the set of all events that are logically possible for the system is simply the union of the alphabets of the component processes. P concurrent Q is equal to P union Q. Example, let us consider example. It will be clear for you how to represent concurrent in different alphabets. Let noisy vending machine. You take noisy vending machine. What are the function of the noisy vending machine? If you insert the coin, you get chocolate. The click sound is made and clunk sound is made, and afterwards you will get toffee. So these are events. These are general events occur in the vending machine. For example, the noisy vending machine has run out of toffee. It doesn't have a toffee. So what happens? If you insert the coin, the sound click will come in because coin inserts. There is a sound made by the coin. Afterwards you generate the chocolate. And clunk is a sound such that the transaction chocolate is generated. That is the sound. So this one, no toffee, so you will get only chocolate. That is the noisy vending machine process. The customer of this machine definitely prefers toffee. The curse is what he utters when he fails to get it. He wants toffee, but curse, there is no toffee in the machine. So what he will do is has then to take a chocolate instead. There is no other option. He has to take the chocolate. So customer, you will have the events coin chocolate curse toffee. These are the events now. Events has changed. Events has increased now. The curse is also placed there because if you don't have toffee, then you have to take chocolate. So what is the customer? Insert the coin first. He wants a toffee. If it is not there, curse, not failed to get it, so you will take the chocolate. That is the notation clearly by using the prefix and choice notations. Concurrent activity, we discuss here concurrent activity mainly. Concurrent activity of these two processes is noisy vending machine and customer with different alphabets you are observing here. Mu x dot coin clink curse chocolate and clunk. Here you have the coin. First you insert the coin, then clink sound. He wants curse, chocolatey ones. Wants toffee first generally. So then it is not failed to get it, so it receives the chocolate. So thus it is a repetitive. That is the concurrent of noise vending machine and customer. Like this, we have so many real-time examples. The best way to explain the concurrency is also dining philosopher, which is denoted by using concurrence notation only. And there are so many real-time applications of these concurrency notations. Thus, CSP notations describe the real-time behavior of the systems. Thank you.